The Pythagorean Theorem dates back at least 2,300 years to Euclid's Elements. I'm going to present the proof given by Euclid. Many other proofs exist too. First, the shorter version. Take a right-angled triangle. Square the length of the first shorter side. Square the length of the second shorter side. Add them up, and they'll equal the square of the longest side. Why? Add a square with sides equal to each length. The areas of the smaller squares, when added up, equal the area of the largest square. Why is that? Well, take a line and separate the two smaller squares and divide the larger square into two rectangles. This rectangle's area equals this square's area. This other rectangle's area equals this other square's area. Adding them all up, the largest square has the same area as the two smaller squares' area added together. So let's prove this side. This square's area equals this rectangle's area. Why? Half of this square has the same area as half this rectangle. That's because the area of this triangle equals this triangle's, same base, equal height, equals this triangle's, two corresponding sides and same angle in between, equals this triangle's, same base, equal height. Hence, these two triangles have equal areas, and doubling them, this square has the same area as this rectangle. Same idea for the other side. This square equals this rectangle in area, so half the square equals half the rectangle in area. Because this triangle and this triangle have equal area, same base, equal height, and it has an equal area to this triangle because of corresponding side angle side. And that triangle equals the final triangle in area because of same base, equal height. Therefore, these triangles have equal area, and doubling their shapes, we see that the area of the square and the area of the rectangle are equal. Adding in the other side's results, we see that the area of the largest square is equal to the sum of the two other squares' areas. Therefore, the square of this shorter side plus the square of that shorter side equals the square of the longest side. Now for the longer version. We have a right-angled triangle, three sides, two shorter and one longer, and three angles. It's called a triangle after all. A right angle, which is 90 degrees, and two other angles. Opposite the right angle is the longest side, sometimes called the hypotenuse. The Pythagorean Theorem says that measuring one short side and squaring it, and measuring the other short side and squaring it, then adding them together, equals the square of the longest side's length. So why is that? Well, add a square of the same length to each side of the triangle. If you add up the area of the two smaller squares, that'll equal the area of the largest square. Because if you divide the largest square into two rectangles with a line that separates the two smaller squares, then this square and this rectangle will have the same area, and that square and that rectangle will have the same area. So let's do this side first. The square and the rectangle have equal area because dividing the two shapes in half gives us two triangles that also have equal area. Why? Because this triangle and another triangle have the same area. They have the same base and equal height. Remember that a triangle's area is base times height divided by 2. Next, this triangle and that triangle have the same area because they have the same measurements. These two sides are equal because they're sides of the same square. Similarly, these two sides are equal because they're sides of this other square. And the angle between these two sides is the same in both cases. There's a right angle in both cases added to the same smaller angle. Squares, of course, have right angles. Finally, this triangle and that triangle have the same area because they have the same base and equal height. So we've shown that these four triangles have the same area. Therefore, these two triangles have the same area. Hence, after doubling their shapes, this square and this rectangle have the same area. For the other side, we do the same steps. This square's area equals this rectangle's area, because this half square has the same area as this half rectangle. These two triangles have the same area, we see they have the same base and equal height. And these two triangles have corresponding sides with the same length and the same angle between them. And these final two triangles share the same base and have equal height. Therefore, all four triangles have equal area, and hence two triangles have equal area, and the square and the rectangle are equal in area. Bringing together the two cases, we see that the largest square has the same area as the two smaller squares combined. Hence, the square of this length plus the square of this other length equals the square of the longest length. And that's the Pythagorean Theorem.